Hello, this is Ms. DB, and today we're going to continue with Chapter 9 on 9.4 Operations with Functions. We're going to do this in two parts. Today we're going to do Part 1, which is to add, subtract, multiply, and divide functions, also called to do operations with functions. And then in the next video we'll do the Part 2, which is to write and evaluate composite functions. So we'll learn about that in the next video. So these are not going to be too hard, except sometimes dividing functions is a little tricky. But we can perform operations on functions pretty much the same way we can on numbers, or more like when we do it with expressions. We can add or subtract, multiply, or divide functions by operating on their rules. So if we're going to add two functions together, it will look like this, f plus g of x. That's how you'd read that. You just add the two functions together, f of x plus g of x. You will combine any like terms and simplify as much as you can. Subtraction is very much the same. F minus g of x is f of x minus g of x. This, you will have to make sure that you subtract every term, or you take the opposite of every term in the second function. Also, where f of x plus g of x, it doesn't really matter which way you do it. It does matter. You have to do the f of x minus the g of x if that's what it says. If the f is first, you have to do f of x first. When you do multiplication, it looks like this. The f and the g are written right next to each other in parentheses. So f times g of x, you're going to multiply the two functions together. There'll be a lot of distributive property stuff to do there. Maybe some FOIL, maybe even more than that. Then the division one is where you put the f of x, if it's f over g of x, the numerator will be the f of x function and the denominator will be the g of x. You cannot let the denominator equal 0. So like last chapter, chapter 8, when we worked on rational functions, we have to make sure that this is not equal to 0. So you will need to say, well, x cannot equal something. And that those you might have to factor, you might have to cancel some things, so you'll have to look carefully at those. All right, so here's some adding. These are the most basic. You just put the two functions together. So we're going to take 4x squared plus 3x minus 1 plus 6x plus 2. You can only combine like terms, so put the x terms together and the constants together, and you can't do any, there is only one x squared term, so 4x squared, then 3x plus 6x is 9x, and then minus 1 plus 2 would be a plus 1. And that's it. That's your answer then. Now here's the minus. I was saying be very careful because you have to subtract every term in the g of x function. So this will be minus 6x minus 2 because this distributes over to both of those terms. So we have 4x squared plus 3x minus 1 minus 6x minus 2. And then here's plus 3x minus 6x, that'll be a minus 3x. And negative 1 minus 2 will be a negative 3. So we have 4x squared minus 3x minus 3. Here's a couple examples from your worksheet. And if we are going to add these together, we're just going to take f of x plus g of x. So we're just going to take what f of x is equal to and then add to that what g of x is equal to. And then we just combine any like terms and simplify as much as we can. So there's only one x squared term, so I just write that down. There's only one x term, plus 2x. There is two constants. We have a minus 1 here and a minus 1 here, so that will give me a minus 2. And that's it, you're done. The second one is a subtraction problem, so I'm going to subtract g of x, which means that I have to subtract every part of g of x. So I have 4x squared minus 1 minus 2x minus a negative 1 is the same as plus 1. So there's, again, only one x squared term and only one x term. This time, though, we have minus 1 plus 1 is 0. You don't need to write that. You can just leave it as this. And then again, don't forget about when you divide, limit the domain. All right, now we're going to multiply. So these are a little bit more work because we'll have to do the distributive property a few times. So we're going to have to take 6x squared times 2x times negative 3, and then minus x times 2x minus 3, and then negative 12 times 2x minus 3. So 6x squared times 2x minus 3 minus x times 2x minus 3 minus 12 times 2x minus 3. And then each part of those needs to be distributed. So we have 6x squared times 2x. That's 12x cubed. Remember, we have an exponent of 1 there. Then we have to take 6x squared times negative 3 would be minus 18x squared. Then we have minus x times 2x, that's minus 2x squared. And then minus x times minus 3. Negative times negative is a positive 3x. And then a negative 12 times 2x will be minus 24x. And then negative 12 times negative 3 will be a plus 36. Okay, now we're going to look for like terms. There's only one x cubed term, but there's two x squared terms. Negative 18x squared minus 2x squared. And then there are two x terms, plus 3x minus 24x, and then only one constant. So that ends up being 12x cubed, then negative 20, because negative 18 minus 2 is negative 20x squared, and then negative 21x, because 3 minus 24 is negative 21, and then add the plus 36 at the end. All right, let's do some division. These are the same functions as on the previous page. It would be nice if they were here. So you set it up, and then you're going to see if you can factor the numerator. If you can factor the numerator, maybe it factors into 2x minus 3 and you can cancel something. But before I go any farther, I want to off to the side think about what it cannot be, because then the denominator would be 0, which is not allowed. So then I would have 2x equals 3 divided by 2. X cannot equal 3/2, because if x was 3/2, I would get 0 in the denominator, and that's not allowed. All right, so now I am going to factor 6x squared minus x minus 12. Now they did that like they had it memorized or something. Here's how I would do that. Put your two sets of parentheses and look for the factors of 6x squared. Now I know it's going to be x and x, but is it going to be 6 and 1 or 2 and 3? A giant hint is that the denominator is 2x. So I'm going to go ahead and assume that I'm going to use 2 and 3 to get 6. So because 2x times 3x is 6x squared, that part will work. Now I have to write the factors of negative 12. So I could do 2 times 6 or 12 times 1 or 3 times 4. And another giant hint is that if I am going to use the 2x minus 3 as one of my factors, then why don't we go ahead and put that, and then the other one would be a plus 4. Because to get negative 12, it's true that negative 3 times 4 would equal negative 12. Negative 3 times positive 4. Let's FOIL this back and see if it works before I go any farther. If it doesn't work, then I have to start over. All right, so FOIL is first times first. That would be 2x times 3x is 6x squared. Then I take the outer times the outer. 2x times 4 would be 8x. Then the inner times the inner. That would be negative 9x. Then the last term times the last term is negative 12. So the first term is good. Add the like terms, I get minus 1x or minus x, and then there's the minus 12. Do these two parts match? If they're exactly the same, and it wouldn't matter if I put a 1 here, that's still the same, then these are the factors. So then you take these factors and you put them here, which they already did. 2x minus 3 times 3x plus 4. Now the bottom was 2x minus 3 already. Now I see that I have a 2x minus 3 and a 2x minus 3. So now that I have the exact same factors, I can cancel. You cannot cancel until you have factored. You cannot cancel through addition or subtraction. You can only cancel whole factors. Okay, so I am left with just the 3x plus 4. But remember, part of the answer is that x can never equal 3/2 or 1.5, because then you would get 0 in the denominator, and that's not allowed. This is just another example, just a little practice, because these are a little bit trickier. So pause the video, try these out, and see if you get the right answer. Okay, so on example 2a, you should have gotten that, you should have FOILed in this case. So first times first and got x cubed. The outer times the outer would be minus 4x. They put that over here. The inner times the inner would be 2x squared. And then the last times the last, it would be negative 8. So then you combine your middle terms. Oh, no, you can't. There is no middle terms. They're all different. So that's your answer. You're done. X cubed plus 2x squared minus 4x minus 8. Or you could write it in a different order. To do the division, it's a little bit trickier. But this one is not bad at all because this is difference of squares. And you can factor difference of squares as x minus 2, x plus 2. Much easier to factor this one than the last one we did. And the x plus 2 will cancel with the x plus 2 that is already in the denominator. Now remember that we cannot let x be equal to negative 2. Did you remember to do that? So our answer is just going to be x minus 2, but x cannot be equal to negative 2. Here's some examples from your assignment, from your worksheet. So let's try number 4. Number 3, you're going to, I'll set it up. You're going to FOIL this one. There's the f of x, and here's the g of x. And then you will take the first term times the first term, and the outer times the outer, and the inner times the inner, and the last times the last. For number 4, we're going to take f of x over g of x. Over g of x. So let's see what that would look like. We would have 4x squared minus 1 over 2x minus 1. Now you may not recognize it, but this part here is difference of squares. We have something squared minus something squared. So that means we can write this as those things, the square root of the first part minus the square root of the second part, and then the square root of the first part plus the square root of the second part. So what is the square root of 4x squared? It's 2x. These are both going to be 2x. And then the square root of 1 is 1. So we're going to have a plus 1 and we're going to have a minus 1. And then the denominator was also 2x minus 1. So you'll see if anything will cancel. And then don't forget that you also have to figure out what x cannot equal as part of your answer. Let's also look at number 8. Here was the functions to use, so we're going to pick the right one. We want k over f of x. So this one over this one. Oh, that's going to be very, very easy. And I don't think I will do the whole thing. Over f of x is just going to be that. And you also have to say what x cannot equal. Let's look at number 9 and see if that one's harder. We have h of x is x squared minus 9. And k of x is 2x. That's also not going to be very hard. You're just going to multiply both parts by 2x. So we will get x squared times 2x. I'll just write it out. Minus 9 times 2x. And then you will simplify both of those parts and find out what you get. So in the next video, we will go over composite functions. Thank you very much and have a wonderful day.